Welcome again to the class. As far as our today's topic is concerned, today's topic will be finding the centroid of a triangularly distributed load. In the previous problem, we have given the definition of the centroid. We know how to find the centroid of simple geometrical figures. We started from the rectangle. Today we will understand how to find the centroid of other geometrical figures. Let's suppose we have a right angular triangle. Let's suppose we have a right angular triangle. We have a right angular triangle, and let's suppose we consider this axis. This axis we consider this axis to be our x-axis, and we consider this axis to be our y-axis. Okay, so we say let this to be our x-axis, let this to be our y-axis, and this is a right angular triangle such that the dimensions of the triangle are this dimension of the triangle, the base of the right angular triangle, and the height of the right angular triangle. Let's consider this dimension to be h. We assume that the height of the right angular triangle is h, and its base is, say, for example, b. And this is the 90-degree angle. This is a right angle triangle, and we have been asked the question is find the centroid of this triangle. Okay, at least we should be knowing, what dimension is very important for us for the centroid. We know from the definition of the centroid that x coordinate of a centroid is equal to integral x dA divided by integral dA, and the y coordinate of the centroid is equal to integral y dA divided by integral dA divided by integral dA. These are the x and y definitions of x and y coordinates of the centroid of any geometrical figure. Now we have to apply these formulas on the centroid of a right angular triangle. What we do, we will find out, first of all, we will consider finding the centroid as far as the y coordinate, finding the y coordinate of the centroid. Once we find the centroid or y coordinate of the centroid, then we can also find the x coordinate, or first we'll find the x coordinate, then we will find the y coordinate. I'll be showing you how to find the y coordinate. X coordinate students can do themselves. Now, in order to find the y coordinate of the centroid of this right angle triangle, it, as we discussed in previous class also, that we have to take an element, we have to take an area element such that the area element has to translate along the y-axis. In order to find the y coordinate of the centroid, we'll be taking the area element such that the area element has to translate along the y coordinate. If we have to find the x coordinate of the centroid, we'll be taking an area element and we'll make the area element translate along the x-axis. Let's first of all find the y coordinate of the centroid. So we will be taking an area element and we'll make the area element translate along the y-axis. Let's start with an area element. So as far as our area element is concerned, we'll take a small area element. We'll take a very small area element out here, and we'll say this area element has having very small area, and the area of the small area element is dA. Okay, this is what we have been doing. This is a basic step that we perform. So first of all, we have to find the we will be finding we'll be taking the small area element. Now, as far as this coordinate, since this area element is very small, the dA is very small, this side is very close to this side, and this side is very close to this side, then we can approximate that this small area element is in the form of an rectangle. This small area element is in the form of a rectangle, though the diagram that we are showing of the small area element makes us understand that this is not a rectangle, but this is an exaggerated diagram. Actually, we are taking this area element to be very, very small. Therefore, this has to be essentially an approximation to a rectangle. Let's suppose, as far as this this rectangle, the width or the breadth of this rectangle is, say for example x. We take its breadth to be x. Now as far as this coordinate is concerned, this is very, very small. So this height is concerned, we say the height of this rectangle is very, very small, that is equal to dy. Okay, this is very small height, we call this as dy. Now, as far as the as far as this area of this rectangle is concerned, the area of the rectangle will be x into dy. Okay, or this is very important also, that we can also start the procedure like this is one way of drawing the area element. Another way of drawing the area element is like we will take as some books have shown, drawing the area element like this is one way of doing it. This, by this way we can also obtain this the centroid. We can also obtain the area element. There's one more way of doing it. That way of doing it is we can do it like this. We'll take a small area element first. Okay, we'll take a area element. Okay, this is one side, and the area element that is has to be in the form of a rectangle will be slightly like this. Okay, this is one more way of doing it. Okay, so by this way, let's consider this to be our small area element, which is in the form of a rectangle, and we say this area element has an area equal to dA. Okay, now this base of this area element dA is equal to x. This base is equal to x, and its height is small, and its height is equal to dy. We say let its height be equal to dy. Now as its height is equal to dy, now see, let's first of all, how much will be the area dA? We can say, as far as dA is concerned, dA is equal to x into dy. Okay, dA is equal to x into dy. X is variable. Okay, x is variable and y is also variable. X and y are varying. uh, X varies, x a variable along x-axis, y is a variable along x-axis. Therefore, if we write dA is equal to x dy, we should know the equation between x and y. Okay, in order to find the area, small area dA, we should know the equation between x and y, because if we are asked to calculate the total area, we have to perform the integration. How can we perform the integration between x with respect to y when we don't know the relationship between x and y? So our first step should be to find the relationship between x and y. In the previous problem of rectangle, we had dA, dA was equal to something b dx. B was constant. Okay, b was constant, so we need not to, there was no problem of finding the relationship between b and x, because b was essentially constant, and the total area was integral of dA, that is integral of b dx. B will come out of integration. Okay, integral dx was equal to x. Okay, this is how we did what we did in the previous problem. But here the situation is different. Here we are getting dA in the form of x dy. So we should know the relationship between x and y. This is very important thing. So in order to know the relationship between x and y, it means we should know how this y varies with x. How this y varies with x, we can easily find, because it means we have to find the equation of this straight line. We have to find the equation of the straight line. Okay, that equation of the straight line will be the equation of y in terms of x. We know, as far as the equation of straight line is concerned, we know the equation of straight line is y is equal to mx plus c. Okay, as far as m is concerned, m is the slope. Okay, as far as this line is concerned, as the value of x is increasing, the value of y is decreasing. It means the slope of the line is decreasing slope, and we know when we have a line with decreasing slope, that slope is taken as negative. Okay, so we'll write y is equal minus m. Now slope will be perpendicular by base, that will be equal h by b multiplied by x. As far as C is concerned, C is the intercept on the y-axis, and that is equal to C is an intercept on that's equal to h. Okay, that's equal to h. So we can write this as, this is equal to, this can be written as, if we take this h by b out, we can write this as y is equal to h by b multiplied by, we can write this as h by b. If we take this h by b, we can write this as inside will be b minus x, because what will happen, h by b multiplied by b, b and b will cancel, you will get your h back. H by b into minus x will be h by b into minus x, you'll get this stuff. Okay, so this y varies the equation of this straight line. The equation of the straight line with slope decreasing can be written as y is equal to, this can be written as y is equal to h by b multiplied by b minus x, h into h by b multiplied by b minus x. This is the equation of our this straight line. Okay, so this gives us the relationship between this x and y. Okay, now from this equation, we can also obtain, from this equation we can also obtain, if we multiply this, this will be by divided by h becomes equal to b minus x. Therefore our x becomes equal to, therefore x becomes equal to, we can write this as x becomes equal to b minus b by h into y. That can be written as x becomes equal to, we can take this b by h out, it will be b by h multiplied by h minus y multiplied by h minus y from this equation, because once you multiply b by h into h and h cancels, you will get b by h into minus y, there will be b by h into minus y. Okay, so this equation, this is the equation for x in terms of y. So if we substitute in this equation, x is equal, if we substitute in this equation x in terms of x, we will substitute b by h into h minus y into d integral into d, sorry, integration with respect to y, then we can perform this integration. Number one. Number two is, see, when we had to find the centroid of any figure, first of all, we have found dA. Our dA is equal to integral x dy, and we know x is b by h into h minus y. Okay, if we substitute this value of x in this equation, we will get this x in terms of y, then this integration can be performed. Okay, we are done with dA. Now we have the problem of this x. In the same way, if you have to find the y coordinate, now we know the value of dA, we have the problem of this y. Okay, we have, what is this y? Y is the y coordinate of the area element. How far this area element is from the x-axis? What is the y coordinate, okay, of this area element? Okay, now see here, if we look at the area element that we have selected, the area element that we are selecting is such that this area element, this point of the area element does not lie on this graph, this, okay. And if we draw these two lines properly, if we happen to draw this rectangle properly, then the area element for us will be essentially of the shape, our area element will be, if we happen to draw this properly, then our area element will be of this shape. This is our area element. Okay, if we draw this rectangle properly, then this will be our area element. And look at this point. As far as this point is concerned, this point does not lie on the graph. Okay, so when this point does not lie on this curve whose equation is y is equal to h by b into b minus x, then you cannot, then this point is out of the equation. Okay, you cannot, we cannot take, we have to find, we have to actually use, if we have to find the y coordinate, we have to see how far this area element is from the x-axis. How, what is the y coordinate of this area element? So one way is we will use this corner. Okay, but this corner cannot be used because this point is out of the y-axis, it does not lie on our curve. Now look at this point. This point has the same problem. You cannot say that our area element is at a distance y from the x-axis, okay, because this point is also not lying on this on the curve. So what we do in this case, we take what we call as, we take the middle point, we take the central point, we take the point, we take this point, the midpoint, okay, this point of this area element. We say let this to be the distance, let this to be the distance y of this area element. Actually, the proper definition is, as far as this y is concerned, you should always remember this y is the y coordinate of the centroid of the small area element dA. Be careful, I am repeating. When you are using this formula, y bar or x bar formula, to find the x and y coordinates of the centroid of an area, then you should always remember, as far as this y is concerned, this y is concerned, this y is concerned, it is the y coordinate of the centroid of the small area element dA. As far as this x is concerned, this x is also the x coordinate of the centroid of the small area element dA. Actually, this is the definition, okay? Now, this is a rectangle. We have previously seen that the centroid of a rectangle lies at its geometrical center, okay? So by the definition, we have to take this distance of the centroid of this rectangle from the x-axis will be taking as y, okay? This is what we have done. Now again, use the formula, use this formula to find the centroid. We will be using, we say y bar of the centroid, the y bar of the centroid is equal to, y bar is equal to y dA, integral y coordinate of the centroid, we are saying y into dA, and our dA is equal to x into dy, okay? We have, this is equal, dA is equal to x into dy, and in place of x we will write b by h into h minus y. So we will write here b by h into b by h into h minus y, okay? So this is b by h into h minus y. So this is our y coordinate, then we have dA is equal to x, we have written this x, and dy divided by integral dA. Integral dA means integral of x, that is b by h into h minus y, this is our x, and multiplied by a dy. Now our variable of integration in this problem is y, and our y varies from 0 to the maximum value of h. So this will be integral from 0 to h, integral 0 to h, okay? We can perform this integration. Therefore we can, once we tend to solve this, this b by h is constant, this b by h will come out of the integration. At the denominator, this b by h will also come out of the integration, b by h and b by h from the numerator and the denominator will cancel. So we'll have integral y into h minus integral y into h dy minus integral y square dy divided by integral of h into dy, h dy minus integral y dy. This is how it will go. And the limit of integration is from 0 to h. This is from 0 to h. So everywhere the limit of integration goes from 0 to h, okay? Then we can, what we can do, we can, let me rub this off, clear some space. We can write this as, therefore this integration then should tend to solve this. This can be written as, this is h integral y dy, this is h integral y dy is equal to y square by 2 going from 0 to h minus y square dy will be y cube by 3 going from 0 to h whole divided by This is h dy, this is h into y going from 0 to h, minus integral y dy is y square by 2 going from 0 towards h, which implies, which is equal to, this can be written as, this is h by 2, this is y square going from 0 to h, this will be h square minus h cube by 3 divided by h square minus h square by 2, which is equal to, this is h cube by 2 minus h cube by 3, that is equal to h cube by 6 whole divided by h square minus h square by 2, that's equal h square by 2, which is equal to h cube by 6 into 2 by h square, and this will cancel. This is 2 ones, this is 2 3. Therefore, it means the y coordinate of the centroid is equal to, y coordinate of the centroid of this rectangle is equal to h by 3. What does that mean? That means if you are asked, you have a right angle triangle, if you have a right angle triangle and you are asked where is the centroid of this right angle triangle, you are given a right angle triangle and you are said the height of this right angle triangle is h along y-axis. Where is the y coordinate of its centroid? The y coordinate of the centroid from the base, be careful, the y coordinate of the centroid from the base from this right angle will be at a distance h by 3. Okay. Similarly, if you are asked to calculate the y coordinate, sorry, x coordinate of the centroid, the x coordinate of the centroid will also come out equal to b by 3, which you can prove yourself, that is left as an homework to you. Now, from this we are getting that as far as the y coordinate of the centroid is concerned, the y coordinate of the centroid is at a distance h by 3 from the base. Okay. So as far as the x coordinate is concerned, x coordinate, what you have to do now, you have to take an area element, but you will be taking your area element now like this. Okay. Take this as your area element, repeat the processes, repeat the steps as we have done here. You will obtain the x coordinate of the centroid will be b by 3. So where is the centroid then? Go along x-axis b by 3, go along y-axis h by 3. The centroid is somewhere here. Okay. So this is the procedure of finding the centroid of a right angled triangle. After understanding how to find the centroid of a right angled triangle, now let's try to solve a few questions. As far as the question is concerned, we have a question here. The question says, determine the resultant force and specify where it acts on the beam measured from A. So as far as the question is concerned, the question is like, we have a beam, the span of the beam is, the total length of the beam is 6 feet plus 8 feet, that is 14 feet. And the load to which this beam is subjected, it is subjected to a trapezoidal type of load. It's a load in the form of trapezium, okay? Because you are having two parallel sides and two non-parallel sides. The load exists in the form of a trapezium, okay? Now we have been asked, reduce this load, find the resultant force and specify where it acts on the beam measured from A. That is, we have to replace this total load by a single load. What we will do, we have load in the form of a triangle. In order to do this type of problem, what we will do, we can easily divide this problem, and we can divide this loaded diagram into two diagrams. We can say that this portion is our right angle triangle. This portion is our right angle triangle. And this portion on the right hand side, this is a rectangle. Okay. So we have two loads, two types of loads acting on the beam. We have the load in the form of a rectangle and the load in the form of a triangle. Now first we find the resultant of this triangle. The resultant force because of the triangle, the resultant force because of the triangle will be equal to area under the triangle, will be equal to area under the triangle, will be equal to area under this triangle, that we will be equal to half of base, that is 6 feet, multiplied by its perpendicular. The perpendicular is the distance from here to here, and that distance is equal to 150 pound, 150 pound per feet. Okay, so feet and feet will cancel. So this is 2 ones, this is 2 threes. So this will be equal to 450 pound. Okay, so it means, so we can write here the resultant force because of the triangular load is equal to 450 pound. Now the question is, where is this load of 450 pound acting? We have already said that the load because of a distributed load system acts at the centroid. Where is the centroid of this triangle? Okay, we know this is a right angle triangle. As far as its centroid is concerned, its centroid will be where? Its centroid will be from the right, from the perpendicular side. It will be at a distance, it will be at a distance 6 by 3, half of the base. That is, the centroid will be somewhere here. We have already found the centroid will be somewhere here. Okay, such that this distance is equal to, this distance is equal to, yes, this distance is equal to a base by 6 by 3. Okay, 1/3 of 6 feet by 3, that is equal to feet. Okay, so it means the question is very simple. Now we can say that this triangle is subjected to a load of, here it is subject at this end, this triangle can be replaced by a single load having magnitude of, 450 pound, and is acting at a distance of 2 feet. This distance is from point A, this distance is 2 feet. Okay, this distance is 2 feet. Now let's talk about this rectangle. The force, resultant force because of the rectangle will be equal to area under the rectangle, and that is equal to its base, that is 8 feet, multiplied by the perpendicular, that is 150 pound, 150 pound per feet. Feet and feet will go, 150 into 2, this is 80, this is 1200. Okay, this is 1200 pound. Okay, and this 1200 pound will be acting at the centroid of this rectangle. So we can say this 1200 pound force is acting at the centroid. Where is the centroid of this? Where is the centroid of this right angle triangle? We know centroid of the right angle is at the center. Okay, it is at the center, geometrical center, such that this distance will be how much? This distance will be 4 feet. This distance will be 4 feet. Okay, and this force will be acting like this. So we have this much amount of force. This force is equal to 1200 pound. Okay, so we have 1200 pound force acting at a distance. Now we can replace all these forces by a single force. What will be the resultant force? You have 450 pound force, we have 1200 pound force. What will be the total force? Now you can repeat the steps as you have done in previous problems. Therefore the total force, the the resultant force, will be equal to, this is 1200 pound force acting in negative direction, this will be minus 1200, this is minus 450, it will be minus 1650 pound force. Okay, this is minus 1650 pounds. So these two forces you can replace by a single force. Where that force will be placed? That force will be placed at a point. Let the distance of that, let the distance where that force is acting, as we have done previously, let this resultant force be acting, this resultant force of 1650 pounds be acting at a distance, be acting at a distance, be acting at a distance x, x from the point A. Sorry, we have to take all the distances from point A, sorry. So it will go like, you have to take all the distances from point A. So you will undo this. Since all the distances are to be measured from point A, So it will be from point A. Okay, so let this distance be equal x. Okay, so now it means, what is the moment of this force about point A? The moment of 1650 pound force about point A will be 1650 multiplied by the distance x. Okay, and this is trying to rotate the entire beam in the clockwise direction. We'll write this as minus. This is equal, the moment because of this 1200, this is minus 1200, because this is also trying to rotate the beam in clockwise direction, and its distance from the point A will be this 4 feet, and this this 6 feet plus this 4 feet, that is 10 feet, that is 10 feet. Then the moment because of this 450 pound force, this is also trying to rotate the beam in clockwise direction. This will be minus 450 multiplied by the distance. This distance is 2 feet, therefore this distance will be 4 feet multiplied by 4. Therefore we can calculate the value of x is equal to 12,000 plus 450 into 5, that is 1800, divided by 1650. Since we are measuring distance in feet, the answer will be in feet. This is 12,000 plus, so you can calculate it now. You can easily calculate it. It will be 12,000, sorry, it is 12,000 plus 1800 divided by 1650. That comes out equal to, you can calculate it, 8 point something. Okay, so this entire force 8.36 feet. Okay, 8.36 feet. It means you can replace 8.36 feet is the distance. It means these all forces can be replaced by a single force. These all forces can be replaced by a single force acting at a distance of from point A, acting at a distance from point A equal to 8.36 feet from point A, such that the magnitude of this force has to be 1650 pound. Okay, so this is how you can replace these loads in terms of a single load. I hope this you have understood the concept. We will continue with few more problems in the next class. Thank you very much.